Okay, so our last section of the Earth science, our last unit of Earth science, is going to be about the carbon cycle and how we have climate change over time. Uh, so, carbon cycle, pretty simple. If you look at this, carbon will move throughout the atmosphere, biosphere, and geosphere, and it will be normally based on the consumption of and respiration of carbon. So, the law of conservation of matter states that it's a law of conservation of matter and mass. It states that mass cannot be created nor destroyed in a chemical reaction. Thus, it cannot change the amount, but the type of matter will change. So, for instance, if you eat a Oreo, it is impossible for you to gain a pound. You can digest it, you can burn whatever you can from that energy, and you will get rid of the waste, or you will contain whatever waste stays in your body. Uh, but you cannot gain any more than that one Oreo. So a geosphere is where fossil fuels and your organic compound is found. So geosphere is underground. Your biosphere is all living things, plants and animals. So that is anything from you all the way to the crustaceans in the ocean. And the atmosphere is everything that is in the air. That is the gases that form our atmosphere, and that would be gaseous carbon dioxide. So atmosphere to biosphere. So you're looking at plants absorbing carbon dioxide and creating energy through photosynthesis. The animals eat the plants to gain the carbon. So photosynthesis, they gain carbon dioxide from the atmosphere, and then animals eat the plants. Biosphere to atmosphere. Plants and animals break down sugars through respiration. So they produce carbon dioxide and it goes back into the atmosphere. Burning plants and animals fuel put more CO2 back too. So just a normal respiration isn't going to overload the system with carbon dioxide. But the fact that we burn fossil fuels, things that have been in the ground for millions of years, carbon that's been in the ground for millions of years, and now it's being burned, is putting millions of gallons of carbon dioxide gas into the atmosphere that it wasn't there before. So we're burning it. Human influence, burning different things. So biosphere to geosphere, this is when plants and animals die. Their carbon bodies decay, and they either turn into a fossil fuel, or they're used, or they burn everything through decomposition, which means that the organics are decomposed into organic soil. Sedimentation means they form fossil fuels. And then geosphere to atmosphere. This would be when volcanoes erupt. That's pretty much the only natural occurrence. Geosphere to atmosphere would be the fossil fuels taken and then burned. That's the one that is human impact. So you can see geosphere to atmosphere, geosphere to atmosphere. And that's basically what the carbon cycle does. Now, there's a lot more impact. So if we go and we look at wrong one. If we look at our carbon cycle here, so carbon plays main four processes in carbon. So you see biological processes such as photosynthesis, respiration, decomposition use carbon. Burial composition and decomposition of organics also uses carbon. Geothermal processes, but mining, cutting, and burning forests and burning fossil fuels has the largest impact. So humans affect the amount of carbon dioxide in the atmosphere. They burn oil and other fossil fuels. They clear lumber from forests, meaning that now instead of those forests taking in carbon dioxide, they're being burned into the atmosphere. Burning down trees to do this is causing a lot of problems. So factories also give off carbon dioxide because they're burning fossil fuels as well. So this can create acid rain. It can create climate change, because think about it. Carbon has to go somewhere. And we've noticed, if you look back at Venus, Venus has a ton of carbon dioxide in their atmosphere, causing it to extreme heat. So that's where we see climate change coming from. So the larger amounts of carbon dioxide in the atmosphere since the early 1900s or late 1800s. But acid rain is one of those things. So precipitation is usually acidic at a low pH, and it can be harmful to different things in there. As you see, there is much more carbon being produced into the atmosphere than oxygen being taken in. This can cause a large problem when it comes to climate change. And just look at this human impact. Humans also have an impact on creating more cattle and more animals that will actually produce more carbon dioxide too than they would normally in nature. So in nature, you wouldn't see billions of heads of cattle, but you do because we consume cattle. And that's the biggest problem when it comes to that. If you look, so I'll actually go into my third section. So if you look, you can see that air quality has gone down since we have started using more carbon dioxide. So this means air pollution is up. So you have harmful substances, including gas and smoke, that are in the air. Some pollution occurs naturally, but the majority of pollutants have come from our human activity. Point source pollution is something that comes from something that is stationary. Non-point source is something from a large spread population. So like a large city or all of the cars that move across the country. So smokestacks are a very big problem when it comes to, but we can see what it is, we can fix that problem. The biggest problem is that we are a moving species, so we will burn different things in different places. So air pollution is just not harmful to human health. It can damage plants, lakes, ponds. It can damage man-made structures. Actually, the biggest problem is that we see that there is a problem with climate change. But when it comes to air quality, you can see that. So acid precipitation, just like we talked about, and then photochemical smog is like a fog, but it comes and interacts between chemicals in the air and sunlight. It only comes from chemicals in the air. Particulate matter are dust and acids and other chemicals that can be harmful to human health. High allergen days are caused by the fact that they are unable to move into the higher atmosphere. So the air quality index is an index that reports daily. If you go to airnow.com, it gives you a report on what your air quality is at this current time. You can go anywhere in the world and they'll tell you what it is. Reports allergens, reports respiratory disorders, what it can be dangerous. The Clean Air Act of 1970 gives the U.S. government power to set standards to protect organisms and structures from your harmful air pollution. So it was becoming a problem in the U.S. in the 70s, and gradually it's gotten better. But this is the impact that carbon has on climate change. You see it in the air quality, you see it in the cycles of nature. You can see that there is a problem with carbon being moved. So that being said, you need to answer the research questions that you're given. That'll be counted as a quiz grade for this section. And then you will take a test over the lectures, and that will be your final test for Earth Science. All right, good luck. Enjoy. This is your carbon cycle. Smart idea to have that. That'll help you on your test.